Alright, so this Codelab is on FIDO2. I'll go back so you can see. I'm on codelabsdevelopers.google.com and I search for FIDO. It's this one, Android FIDO application. So I'm going to click start, and alright, here we go. Your first FIDO2 API. About this Codelab. Intro. What is FIDO2 API? FIDO2 API allows Android apps to create and use strong, attested, public key-based credentials for the purpose of authenticating users. The API provides a WebAuth and client implementation which supports the use of BLE, NFC, and USB roaming authenticators, those security keys like the YubiKey, Yubico, as well as platform authenticator, which allows the user to authenticate using their fingerprint or screen lock. What you'll build. In this Codelab, you're going to build an Android app with a simple re-authentication functionality using fingerprint sensor. We're actually going to use facial recognition because the Pixel I have does not have a fingerprint sensor. Re-authentication is when the user signs into an app, then re-authenticates when they switch back to your app or when trying to access an important section of your app. The latter case is referred to as step-up authentication. What you'll learn how to call the Android FIDO2 API and options you can provide in order to cater various occasions. You will also learn re-auth specific best practices. Warning, you won't learn how to build a FIDO server. Server implementation in this Codelab is a stab. Please don't use it or the library for your own production environment. You can find third-party solutions at FIDO Alliance official page or open source libraries at webauthn.io or awesomewebauthn. We are looking for your interest, blah, blah, blah. Okay, what you'll need, Android device with the fingerprint sensor. I have that. And then Android OS 7 or later. Got that. Okay, next. Getting set up. Clone the repository. Okay. I'm just copying the get address, not the command. And then I'm starting Android Studio, get from VCS, and I'm gonna paste that right there. Clone. Let that do its thing. Okay. What are we going to implement? Let's let users register a user verifying platform authenticator. The Android phone with fingerprint sensor itself will act as one. Okay. Let users re-authenticate themselves to the app using their fingerprint. You can preview what you're going to build from here. Oh, it's an APK. Let me see. Oh, I'll just make one myself. Okay, start your Codelab project. The completed app sends requests to a server at that website. You may try web version of the same app there. You're going to work on your own version of the app. Go to the edit page of the website at this website. I'm going to go there. Find Remix to Edit button at the top right corner. By pressing the button, you can fork the code and continue with your own version along with the new project URL. Okay. Remix to Edit. Cool. Copy the project name on the top left. You may modify the .end file, hostname section, and glitch. Okay, here's the name. Yours is going to be different, so don't use mine. and it says in the .env file right here, .env, and where do we put it? In an environment variable, host name. Okay, so we have to make an environment variable right there. We'll do add variable, and it was host underscore name, and we'll paste that right there. Is that right? Oh, we have to do .glitch.me. .glitch.me. Is that right? Now let's see. Yep, the name .glitch.me. Okay. Next. Digital asset links. To use FIDO2 API and Android app, associate it with a website and share credentials between them. To do so, leverage the digital asset links. You can declare associations by hosting a digital asset links JSON file on your website and adding a link to the digital asset link file to your app's manifest. Okay. So it's like a way to link your Android app with a like a web, your server, your web API. All right, you can define an association between your app and website by creating a JSON and put it at .wellknownassetlinks.json. All right, this is on the host. This is on the server. Okay, luckily we have a server code that displays assetlinks.json file automatically just by adding the following environment params to the .env file in glitch. Okay. Android package name of your app. Okay, so once you have that cloned, you got to do one more thing. You actually don't want that. So go into File, click Open, and change it just to make it easier. And select Android. You want just the Android, because all that other stuff is Node for the server side code. We don't want that. So I selected Android, and I click Open. And I'm going to do it in this window. I trust the project. Okay. All right. So we need the package name and the SHA-256 hash. So let's get the package name first. I'm going to change this to project view. I like project view better. Package name, I'm just going to grab it right here. It's this com.example.android.fido2, not the UI. That's specific to this package. Alright, so go here, package name, put it in there, paste it there, and now we need the hash. The default password is right there. Oops, that didn't work. Alright, I copied that command. I have to change it though. Okay, see, gotta get rid of that $sign. Alright. Only one command is allowed. Export cert and list were specified. Okay, let's do just list. Alright, just doing list. And the password for the debug key store it's Android, all lowercase. That's for the debug key store. There's my SHA-256. That's what I want. I want that hash, so I'm going to copy it, paste it right there. Alright, let's check the logs, see. Okay, so every time you make a change, it'll bounce the server for you, which is nice. You don't have to manually restart. Okay, that's good. What's next? Alright. By accessing this URL, you should see a JSON string like that. So I'm going to copy it. We have to change from alright. Okay, there we go. Nice, nice. You should see that JSON. I see it. Open the Android, the project in Android Studio. I did. Okay, open the project in Android Studio. Open an existing Android Studio project. I just did that previously. Choose Android folder. That's the one I chose. Associate the app with your remix. Open Gradle properties at the bottom. Change the host URL to the glitch remix you just created. Okay, that's in Gradle properties. So right here. And I gotta get rid of that and change it. Oh, that's not it. Hold on. Oh, yeah, it is. There we go. Sync it. Alright, at this point your digital asset links configuration should be all set. Cool. So now I've tied this Android project with, interesting, I've never done that before. Okay, see how the app works now. Let's start by checking how the app works now. Make sure to select combo box, click run to launch the app on your connected device. When you launch the app, you'll see the screen to type your username. This is username fragment. Okay, so I'm going to run this on an emulator at first. Okay. Okay, so this is the username fragment. For the purpose of this demo, the app and server accept any username. Just type something and press next. Okay. Alright, the next screen is the auth fragment. This is where the user can sign in with the password. We will later add a feature to sign in with FIDO2 here. Again, for the purpose of this demo, the app and server accept any password. Just type something and press sign in. Okay. Alright, I just ran it. Oh, did I do the right config? I did. App start. Awesome. Alright, so I'm just going to type the letter A. Do next. Welcome, A. And that's my password is A. Alright, cool. Alright, the last screen. This is the last screen of this app, home fragment. For now, you only see an empty list of credentials here. Pressing re-auth takes you back to auth fragment. Pressing sign out takes you back to username fragment. Okay, so the auth fragment was the one with the password. So re-auth takes you back to the password screen. Okay. And sign out takes you back to the username screen. Okay, the fab with the plus sign, it doesn't do anything now, but it will initiate a registration of a new credential once you have implemented FIDO2 registration flow. Alright, before starting to code, here's a useful technique. It's how to find your to-dos. I like to let them surprise me. Okay, register a credential using a fingerprint. In order, I'm going to stop Android Studio, or stop the app. Okay, in order to enable authentication using a fingerprint, you'll need to register a credential generated by a user verifying platform, a device embedded authenticator that verifies the user using biometrics such as fingerprint sensor. Okay. As we have seen in the previous section, the floating action button doesn't do anything now. Let's see how we can register a new credential. Call the server API. Auth register request. Open auth repository Kotlin file and find to do auth repository. Oops, right here. And find to do one. I can't find it. Oh, am I looking in the right one? Oh, I'm looking in the wrong one, that's why. I want to look in app start. Okay, here's to do one. Let's see. Here, register request is the method that is called when the fab is pressed. We'd like to make this method call the server API auth/register request. The API returns an API result with all the public key credential creation options that the client needs to generate a new credential. We can then call get register pending intent with the options. Okay, so our API, the backend server, is going to drive what kind of options, what we're going to create. So it's very backend API driven. Okay, cool. Because you see there, the API result is what determines what public key credential options the client needs to generate. Okay, we can then call get register pending intent with the options. This FIDO2 API returns an Android pending intent to open a fingerprint dialog and generate a new credential. And we can return that pending intent to the caller. The method will then look like below. Okay, so let's look at the function. It's this FIDO2 API client. You call let on it, do a little null check, and then try catch. Okay, you get a session ID. Caller server API register request. Use register request to get an API result. Okay, so we need to get everything in this when. That's the only stuff that's not there, right? Yeah. Do we need to import this? Yeah, we gotta import that. Alright. Okay, so let's look at this code. So when you got this variable API result, it's set equal to our API. I'm gonna command click that API, see what it is. It's an auth API. Auth API, I assume it's okay, let's see. It's a class, it has an OK HTTP client. Okay, and it just makes network calls. Okay. Interesting. It's too bad they couldn't use retrofit. This is not quite as nice to read. Oh, and I see these responses are unique to that FIDO2 API. So everything's very formalized, I see. Like register response. You can see, okay, like this response is from that credential. That's a class from the FIDO2 class. Okay, I see, and there's the response, call. Okay, so let's go to, I'm going to go back to where we just were, right here, and I'm going to look at this request, register request. Okay, so there's the OK HTTP client, new call, request builder, the base URL is already set, register request, we add a header, put a little cookie in there. How does it format it? Let me see. Okay, so it does session ID key and then the session ID, connect out session ID. Okay, that's pretty straightforward. Let me go back. Okay, the method, JSON request body, it's a post request. Name attestation, value is none. Authenticator selector, object value, name, authenticator attachment value, platform, user verification is required. Okay. Response call await. It's kind of like JavaScript with async and await. Let's see, response result, that gets returned. Parse public key credential options, creation options. It's going to do the body. If it's null, then it throws this API exception. Let's see this parse. How does it parse it? Okay. It grabs the JSON and then it iterates over it. While so if it's a user, set the user. What's the builder? Builder is okay, I see. Public key credential creation options builder. Challenge, it's a string decode. Okay, base 64 encoded string. Public key credential parameters. Timeout, attestation, skip value. I wonder if some of these things, are they actually supposed to be skipped, or for the sake of this example they're just skipping it. I think that should probably not be skipped in a real production environment. Authenticator selection. Okay, RP, I don't know what RP stands for. Alright, so we get that API result. API result signed out from server. What is this? It's an object. API result. Okay. What does this return? It returns an API result. Oh, so this is when. I see. So when the result is signed out from server, you force a sign out. When the result is success, you do what's inside here. So you get that result. If the session ID is not null, you get data store, which is kind of like shared preferences. Basically is preferences. So yeah, let's see, you edit the data store and then you put it in that key, the session ID, and you put what came back from the API. And then you have a task here, client. What is client again? That's the FIDO2 API client. And you register a pending intent with this API result data. So everything's very formalized. There's no like custom, make your own header, make your own anything. It's all very formalized, very interesting. I could see that being really good, but also kind of really bad, because if you're not familiar with it, it's gonna be kind of, that's the learning barrier right there. Okay, a task, await, what does that return? Oh, it returns a pending intent. Okay. Can we look at this code? Not really. Okay. Alright, so that's what that does. When is this called again? Register request, when is that called? Okay, so when that add button, that fab, when that's called, that's how we initiate the credential addition, adding of a FIDO2 credential. Okay, so it returns that pending intent, and that's what we're going to use to open a FIDO2 means of authenticating. In this Codelab it shows fingerprint, but on my device I have a facial recognition. Okay, open the fingerprint dialog for registration. Open homefragment.kt and find to do to home fragment. Oh, here we go, home fragment. I'm already there. To do to, I'm looking at it. I see. Alright. This is where the UI gets the intent back from auth repository. Here we'll use the create credential intent launcher member to launch the pending intent as we got the result from the previous step. This will open a dialog for credential generation. Alright, so what do we have so far? We have just, alright, there's a null check on that intent. So we need this. I don't know why this error is showing up, but obviously it works even with these errors. So, alright, create credential intent launcher. Where is this from? Okay, so it's a, I think it's one of those contracts. Is that a contract? Activity result contracts. This is the new way of starting an activity for a result. And let's see, on the result it says handle create credential result. Okay, so this is what gets called, this is the on activity result, sort of the new way of doing it. So you get that result. Oh, and here's to do 3. Is that where it says to go next? Yeah. Receive activity result with the new credential. Open home fragment KT and find to do 3. This handle create credential result method is called after the fingerprint dialog closes. If a credential was successfully generated, the data member of the activity result will contain the credential information. First, we have to extract a public key credential from the data. The data intent has an extra field of byte array with the key fido.fido2 key credential extra. You can use a static method in public key credential called deserialize from bytes to turn the byte array into a public key credential object. Okay. Next, check if this credential object's response member is an authentication error response. If it is, then there was an error generating the credential. Otherwise, we can send the credential to our backend. Alright, so let's look at the code real quick. We need to fill out this else. So let's see. First, it checks to see if it's okay or if it's not okay, or if bytes is equal to null. Else, so this is where the successful, inside this else, if it was successful. Okay, let me import that. Import that. Oh, I need to import this as well. That might be the error I was getting here. Okay, let's see, credential. Okay, so this is the static method, deserialized from bytes. You pass those bytes. Where does it get these bytes though? When do those bytes, okay, there's gotta be something to initialize those bytes. Oh, right here. Okay. Let me get rid of that one. Import that. Okay. So the bytes, activity data result, you get the byte array extra, and that's the key that you pass is this. FIDO2 credential extra. Okay. Okay, so it does check to see if it was okay, checks to see if the bytes are null, and then if all that's good, then it goes in here. Deserialize from bytes. That's going to give us this public key credential, right? Yep. Okay, so it's like a deserializer. Alright. Response equals credentials.response. If response is authentication error response, show an error message. Else, viewModel.register response. Let's look at this. Alright, viewModel scope. Launch this. Okay, processing value. This must be a flag to control the progress loading bar. And then let's see, register. You get the repository and then register a response, and you pass that public key credential. Let's look at that. All right, here's the next to do. Finishes registering a new credential to the server. This should only be called after a call to register request in a local FIDO2 API for public key generation. We did all that. All right, so let's keep going. Call the server API, auth register response. Open a auth repository Kotlin file. Find to do for, we already did. This register response method is called after the UI successfully generated a new credential, and we want to send it back to the server. The public key credential object has information about the newly generated credential inside it. We now want to remember the ID of our local key so we can distinguish it from other keys registered on the server. In the public key credential object, take its raw ID property and put it into a local string using base64 encoding. Now we are going to send the information to the server. Use API.registerResponse to call the server API and send back the response. The returned value contains a list of all credentials registered on the server, including the new one. Finally, we can save the results in our data store. The list of credentials should be saved with the key credentials as a string set. You can use string set to convert the list of credentials to a string set. Okay, I didn't know about that. In addition, we have the credential ID with the key local credential ID. All right, let's see where. So in this try statement, everything inside that try statement, except for the session ID. Let's grab that. To base 64, we got to import that. Looks like an extension function. Okay, so we grab the session ID from the data store. Credential ID is the credential that gets passed in. It's raw ID. Let's see what else is on here. I'm going to see. So it's ID, raw ID. Oh, that's a byte array? Raw ID is a byte array. Okay. Is that what was checked here? Bytes? No, those are, is that, yeah, it's a byte array, isn't it? Bytes. I wonder, the credential gets passed in. No, never mind. Okay, going back. Okay, so the raw ID is a byte array. Interesting. It has an ID. Can we probably can't really see anything in here. We have to go online to look at the documentation probably. Okay. Okay, let's see what else. All right, so we get the credential ID, and then looks like we make an API request. That's the result. We call register response. We pass the session ID and the credential. Let's look at that real quick. All right, the credential session ID, and it returns a list of credentials registered on the server, including the newly registered ones. So all the credentials it has. Okay, and then here's the call. You grab that FIDO client, new call. Actually, I'm gonna look at, so FIDO. Oh no, the HTTP client. My bad. Okay, the HTTP client. Make a new call. You request. There's the URL, the cookie. It's a post method. ID. You pass the raw. Oh, I see. You get that byte array and then you encode it to base 64. Okay. And then the response is an object, and you give it client data JSON, and that's also interesting. So this response, you cast it to this, and this is from the FIDO as well. Authenticator attestation response. Okay. Where'd that go? Okay. Alright, let me close some of these out. Make a little more space. Where was I just at? Okay. API register response. Go in here. Okay, post request. Okay, public key. What is this? Is this the actual public key? Or is this a recently not null? So I think that's the actual, no, that's the type. The attestation object is the byte array. Okay. That's a byte array. So yeah, it looks like base 64 encode everything. And then pass it to the server. And okay, this type, yeah. So that is a public key credential type to string. Okay, so it's an enum. I see. The ID is the ID. That's straightforward. That's the raw ID of the credential. I see. Credential response. I'm not sure what client data JSON is, but the attestation object is probably the key. Okay. Alright, and that returns a list of credentials, right? Yep, list of credentials. These are, what type are these? These are, oh, so these are a class for this project, so it's an ID. It's an ID for that credential and the public key. Okay, interesting. Alright, so if it's successful, we'll assume that goes successfully. We grab that data store object, and we store the session ID. Okay. The credentials, and that's a string set. There could be more. And then local credential ID. Where does this come from? Okay, that's the raw. Oh, I see. That's the raw ID. Okay, let's keep going. Run the app and you'll be able to click the fab and register a new credential. Alright, I'm going to run this on my phone. Alright, just ran it on my physical device. B for username, B for password. Let's add. Oh, there we go. I put my face in front of it. Confirm. And there we go. There's my public key. Alright. Keep going. Just ran on my device and it worked. Alright. Authenticate the user with the fingerprint. We now have a credential registered on the app and the server. We can now use it to let the user sign in. We are adding fingerprint sign-in feature to the auth fragment. When a user lands on it, it shows a fingerprint dialog. When the authentication succeeds, the user is redirected to home fragment. Call the server API. Open auth repository, Kotlin file, and find to-do 5. The sign-in request method is called when auth fragment is opened. Here we want to request the server and see if we can let the user sign in with FIDO2. First, we have to retrieve public key credential request options from the server. Use API.sign-in request to call the server API. The returned API result contains public key credential request options. With the public key credential request options, we can use FIDO2 API get sign-in intent to create a pending intent to open the fingerprint dialog. Finally, we can return the pending intent back to the UI. Okay, so the register intent is different from the sign-in intent. I wonder why or how. Okay. Let's see. Finally, we can return the pending intent back to the UI. So we need to go to auth repository and find to-do 5. There we go. All right, starts. Let's see. What was the other one? Register response. That returns a pending intent, right? No. Register request returns a pending intent. So we'll compare register request and sign-in request. I'm curious to see what the difference is. Okay, so far we have session ID and credential ID, and we need everything below it inside that statement. Okay, so we get that FIDO2 API client, session ID, we get that from the data store, credential ID, data store. Okay, and that's the one we just created. That's the local credential ID. Okay. And that refers to, yeah, the one we just created. So, okay, if credential ID is not equal to null, so there's a little null check there. All right, when val, we get the API result, and we call this sign-in request. Let's see what that sign-in request looks like. Sign-in request, it takes a session ID and credential ID. There's the call. OK HTTP client, new call, we make a request, we build it. Okay, so we append a query parameter with the credential ID to that URL. Okay, and that's the credential ID of this device. Okay, add header, we put the cookie there, it's a post. And it's an empty JSON body. Interesting. Call await. Okay, so yeah, this is just a pending intent. Okay, I see. But it's still an OK HTTP. Okay. Interesting. So this parse. Response result, parse public key credential request options, and that returns the body, response body. Where's it getting body? Okay, response body. Oh, I see. Oh, right here. This response parse, so that's coming from this response. Okay, I see. Okay, this is kind of confusing. Let's see. So you make that network call right here and you get a result. Okay, so the result must be formatted appropriately to be parsed right here. But it's weird because the request, you're not really sending anything. You're just sending, let's see, you get the client, the OK HTTP client, and you just make a post request, and you pass the credential ID. Okay, what does parsing it look like? Public key. Okay, this is a FIDO2 class. and it returns request public key credential request options. Gosh, the names are so long. All right. You get a builder. It's a builder object. Okay, JSON reader. So you read the body, the response body. Okay, the challenge builder.setChallenge. It's a decode base 64. So it's a base 64 encoded string. User verification skip value. Okay, so I feel like in a production app you would not skip value. Yeah, that doesn't make sense. Okay, builder set allow list parse credential descriptors, allow credentials, RPID, timeout. Okay. Alright, where was, okay, sign in request. Okay, now we're back, and then you get that result. Client, and this client is our FIDO client, correct? Yes. And then you get a sign pending, get sign pending intent. Okay. And you pass it that data from the API result. Okay. Alright. And then it fires off that task, that FIDO task. Alright. Okay, so now to open the fingerprint dialog to, before we do that, I want to compare these two. Sign in request. Let me minimize this. That's a register response. I want to see. Okay, so register request, that's the one I'm comparing, right? Yeah, so you get that request, and the same thing. Okay, so you get the session ID. That seems to be the only thing you really get back. No, and then in here, you get that API result. What's in the API result? All this stuff. Okay. And it looks like, okay. And then that's for a register request. And then for sign-in request, they are different. Okay, but the pattern's similar. You follow the same formal steps. Okay. Alright, this is pretty much the same as we did for registration. I did notice that. We can launch the fingerprint dialog with sign intent launcher. Okay. That's an auth frag. Wait, did I do the other one? Yeah, I did add that. Okay. Now open fingerprint dialog for assertion. Okay, let's go to auth fragment. Where's auth fragment? Do I have that open? Well, let me stop this. Is this okay? Right here. Oh, where'd it go? Right here. To do 6. Launch when started. Open the Fingerprint dialog by launching the intent from FIDO2 API. So what do we have so far? We just have this view model, sign request, collect. Okay, and we gotta pass it this. Okay, intent sender request. Where's that from? That's an Android activity. Let's see, overload, resolution, ambiguity. All these functions match. So we should probably can we say do we need to cast it as pending intent? Oops. Sign in request. Why is it ambiguous? Oh, it's because of these. We have to import this. Which one is it? Which import is it? Oh. So that has to do with something with Gradle, class path. I don't know, it works, so I'm just gonna leave it as is. Let it, okay. Alright, that sign in intent, it launches, that's a pending intent. Intent sender request builder. Okay, so it's just like a pending intent launcher. Alright, handle the activity result. Open auth fragment and find to do 7. Again, this is the same as what we did for registration. We can extract the public key credential, check for an error, and pass it to the view model. Okay, so here's this. Okay, handle sign result. Let's find this. To do 7 right here. Alright, so we gotta fill this out. We gotta get that byte array. I'm gonna grab that byte array. Alright, and then we have to grab this, everything in this else case. Import this stuff. Import that. Okay. And it's pretty much doing the same thing as before. Deserialize from bytes. You get the response. Response is authenticator error response. Check that. And then call the view model sign in response. What's that doing? Pretty much the same as before, except calling sign in response with that public key credential. Okay. And here's the public key credential. So this is our last step. Okay. Open auth repository, Kotlin file, find to do 8. The public key credential object has a credential ID in it as key handle. Just like we did in the registration flow, let's save this in a local string variable so we can store it later. We are now ready to call server API with API sign-in response. The return value contains a list of credentials. Warning. This server-side verification of the signature is core of WebAuthn. However, in this Codelab, you won't learn how to build a FIDO server. That's too bad. The server implementation is a stub. Please don't use it or the library for your production environment. You can find third-party solutions. Yeah, you guys already posted this. You guys are really looking for that. A FIDO server node developer. I am not it. Sorry. All right, at this point, the sign in is successful. We have to store all the results in our data store. This list of credentials should be stored as string set with the key credentials. The local credential ID we saved above should be stored as a string with key local credential ID. Okay. Finally, we need to update the sign-in state so that the UI can redirect the user to home fragment. This can be done by emitting a sign-in state signed-in object in the shared flow named sign-in state mutable. We also want to call refresh credentials to fetch the user's credentials so that they will be listed in the UI. All right, cool. Let's see what else. All right, username, data store username. Okay, let's see, try. So we need to put this in that sign-in response. This is in the last to do. So we already have username and session ID, everything below that in the try statement or try clause. Username and session ID are there. Okay. So we get the credential ID. We encode it base 64. I'm gonna get rid of this. Okay, we encode it base 64. And we call this API sign-in response. We pass it the session ID and the credential. Okay. Let's see what that looks like. Session ID. All right, and credential. All right, we get the credential, we get that raw ID. It's a byte array, right? Let's see. Yep, it's a byte array. We encode it, base 64 encode it. Response is credential.response, authenticator response. And then we cast it as authenticator assertion response. Okay. All right, so we make a network call, the request, we put a cookie in it just like before. It's a post request. The ID is the raw ID from the credential. Okay. The type, and then we put raw ID, which is also the same one. I wonder if that's correct. It seems off. What's register do? Yeah, register was raw ID for both, so it must be correct. Okay, and then the response, we get an object, client data JSON, authenticator data, base 64 encoded. So these are all, okay, and there's the signature, and then user handle. So there must be something, something gets signed with that key, and then it gets validated server side. That's how it determines whether or not that actually is you. You actually did authenticate. Okay. We get the response, parse user credentials, and that's a list of credentials. Okay, so that's the same one. Same as registering. Okay. Run the app and click re-auth to open auth fragment. All right. I'm going to run it on my device. Alright, just ran it on my device, and as per the instructions, it says run the app and click re-auth. So I'm going to hit re-auth, and it crashed. And there we go. It's successfully re-authenticated. I don't know why it crashed before. I followed the instructions. I saw the error. What does it say? There was an error. I believe it was a null pointer, but I don't know. I just had to run it again, and it worked. Alright, so there we go. Ran it, and it kind of worked well. I think maybe that null pointer was just, I don't know, maybe just needs some update from the Gradle. Maybe there's that conflict, the class path screwing something up. Alright, let's go. Congratulations, you've successfully finished the Codelab. Yes. Alright, your first FIDO2 API. Well, that was not an easy one. I mean, I understand more, but I feel like to really understand it, you probably need to do something server side and learn how to build it server side to really see the whole picture and how this could be used. But I could see it being really interesting. You could add an extra layer of encryption once you have the server side. Once you have that public key server side, you could then encrypt everything you send to that user with that key, which would be pretty nice, pretty cool. But anyways, thanks for watching. I hope you enjoyed the video, and go ahead and like it, and I'll keep making them.